Welcome to this explainer. Today, we're taking a massive leap into the future of space exploration. We're looking at the actual, concrete plans and the cutting-edge tech designed to establish a permanent human city on the Red Planet by 2040. Grab a seat and get comfortable, because we're going to break down exactly how humanity plans to conquer the stars, step by step. It's going to be an absolute wild ride. Okay, I want you to just imagine this for a second. The year is 2040. You open your eyes, and you aren't waking up to a blue sky or the sound of birds. No, you're waking up 140 million miles from Earth. Outside your heavily reinforced window is this sprawling, harsh, rust-colored desert stretching as far as you can see. The sky above, it's a dusty butterscotch color, and the gravity pulling you out of bed feels unusually light, only about a third of what you're used to right now. You're a pioneer. You are a citizen of Mars. But how exactly did humanity pull this off? Well, before we can even dream of building a city, we've got to get there. Section 1, Transport to the Red Planet, How Mars Missions Work. Okay, let's dive into this and look at the incredible engineering challenges required to even reach the planet. It all comes down to three incredibly complex phases. First up, the Earth launch. We're talking about colossal next-generation reusable rockets pumping out millions of pounds of thrust literally just to escape Earth's gravity well. Once we break free, we hit phase 2. Deep space transit. The spacecraft basically coasts through the dark vacuum of space for roughly 7 to 9 months. It relies on mind-bendingly precise orbital mechanics. You're essentially aiming not for where Mars is, but where Mars is going to be, catching the planet at the exact right position in its orbit. Finally, phase 3, arguably the most terrifying part, the Mars landing. The ship hits that thin Martian atmosphere at thousands of miles per hour. It has to endure scorching heat, deploys supersonic parachutes, and fire retro rockets in this perfectly timed, fully automated sequence just to touch down softly in the red dirt. Crazy, right? But once the dust settles from that landing, the reality of the environment really sets in. Section 2, the invisible killers, radiation and atmosphere. Here, the stakes couldn't be higher, and we really need to shift our perspective from the thrill of the ride to the deadly, unforgiving reality of the planet itself. Which brings us to a massive question for the colonists immediately stepping out of the ship. But how do we survive the invisible killers? Mars is fundamentally hostile to human biology. To actually build a city there, we have to understand exactly what makes it so incredibly dangerous. So on Earth, we totally take our safety for granted, right? We're constantly shielded by a thick atmosphere and a massive protective magnetic field, our magnetosphere, that harmlessly deflects lethal cosmic rays and solar flares. But Mars lost its global magnetic field billions of years ago. It has virtually no magnetosphere, and its atmosphere is super thin and made of toxic carbon dioxide. So without that magnetic shield, deep space radiation constantly bombards the surface. And why is this so dangerous to people? Because long-term exposure to high-energy solar particles literally rips apart human DNA. It leads to severe cellular damage, illness, and ultimately death. So yeah, you absolutely cannot just pitch a tent on Mars. You need serious armor. But instead of hauling incredibly heavy radiation shields all the way from Earth, we're going to use what the planet already gives us. Section 3, Ingenuity on Mars, Utilizing Hidden Resources. It's time to look at some brilliant local adaptations. Now, what's really interesting about this slide is that Mars secretly holds the keys to our survival. It's not just a dead rock. Beneath that dry, dusty surface, there are massive deposits of subsurface ice. And that ice is absolute gold. It can be mined and melted for drinking water, and even split chemically into hydrogen and oxygen to create breathable air and, get this, rocket fuel for the trip home. And what about that red dirt everywhere? It's called regolith, and it turns out it's the ultimate free construction material. So how do we actually use that dirt? How do Martian 3D printers work? Well, long before human crews ever arrive, autonomous robots will land on Mars. Step 1, they harvest that local Martian regolith. Step 2, they process and mix it with specialized polymers or local water to create a tough, concrete-like building material. And step 3, giant robotic 3D printers extrude this material layer by layer, working day and night in the silent Martian desert. They'll literally print our houses from the ground up. These structures will have walls several feet thick, which is dense enough to completely block out that deadly space radiation we just talked about. Okay, so with shelter secured and water mining underway, what about food? You obviously can't rely on supply drops 140 million miles from home. Enter the Martian greenhouses. How are these vital systems arranged? Well, they're completely enclosed, pressurized, climate-controlled biodomes.
Since the outside soil is totally toxic and filled with perchlorates, you can't just plant seeds in the ground. Instead, crops will be grown hydroponically or aeroponically inside. They'll use that locally processed water and specialized LED lighting tuned to the exact wavelengths plants need for optimal photosynthesis. Not only do these greenhouses solve the massive hurdle of sustainable food production, but they also provide a crucial psychological boost for the crew. Just imagine it, a little green oasis in a totally red world.
So we have the immense rockets, the printed radiation shields, and the high-tech biodomes mapped out. But what about the human element? Section 4, Daily Life in 2040, the First Colonists. What is it actually like for the people living their day-to-day lives in these pioneering settlements? Let's move to and see how this builds over time. Year 1 is all about pure, rugged survival and setup. The first arrivals are entirely focused on checking life support, securing the initial base, and keeping an eye on the robotic equipment. By year 5, we see habitat expansion. Colonists are out there actively directing those 3D printers and building out new interconnected living modules. Fast forward to year 10, and early city operations are in full swing. We're talking dedicated scientific labs, complex maintenance routines, and large-scale agriculture. And by 2040, this fragile little outpost transforms into a bustling Martian city. Daily life means waking up in your printed habitat, throwing on a pressure suit, and heading through secure tunnels to work in a biodome, a research lab, or even a rover garage. It's really about contributing to a tight-knit, fully functioning off-world society where your job is literally critical to everyone else's survival. Building this city requires an unimaginable amount of effort, resources, and extreme personal risk. Which leads us to the ultimate philosophical conclusion. Section 5, the big question. Why become multiplanetary? Why take on such a monumental, dangerous effort to leave our perfect home in the first place? So, the crucial point is really wrapped up in these 3 primary driving forces. First up, ensuring species survival. Having all of humanity living on one single planet makes us completely vulnerable to Earth-bound extinction events, things like massive asteroid impacts or global catastrophes. Mars basically acts as a backup hard drive for human consciousness. Second, forcing massive technological leaps. The sheer, overwhelming difficulty of surviving on Mars forces us to invent incredibly efficient, sustainable energy, water recycling, and medical tech. And those inventions, they will inevitably make their way back to directly benefit life right here on Earth. And third, fulfilling the human spirit of exploration. It's just deeply ingrained in our nature to push boundaries, to see what's over the next horizon, and to conquer the unknown. We've looked at the massive rockets, the deadly radiation, the robotic printers, and the grand, soaring vision for a bustling city in the red dust. But listen, all the technology in the universe means absolutely nothing without the people willing to actually go. So, could you handle the life of a first colonist? Leaving behind the blue skies, the open air, and everything you've ever known? Risking it all to build a brand new world millions of miles away in the dark? It's an incredibly inspiring thought to leave you with. Thanks for joining me for this explainer, and keep your eyes on the stars.